Hi there, this is Penelope, FS3128. This is topic 5, class 1, where we're starting to look at functions and graphs. A function of a variable, whether the variable is x or t or whatever, is just a rule that is describing how that variable x can be manipulated to form or generate y. And often we write it as y equals f of x, so that's y equals some function of x. But for this one here, we could write y equals x plus 2, for example, because we're taking x, we're doing something to it, it goes through a machine, and out spits x plus 2. So we could write that in words. It says take the input and add 2. So if we had another one that said y equals 2x plus 3, that says take the input, multiply by 2, and add 3. So it's just taking a value, taking a variable, say x, manipulating it in some way to form y, or the output. Now the input is generally described or referred to as the independent variable, and the output is generally referred to as the dependent variable, because it depends on what you put in. The idea of a function is a bit like cause and effect. The main idea is that functions enable us to see how two variables are related. For example, in real life, the amount of GST paid depends on the selling price. And for those of you who are civil engineers, the deflection of a beam depends on the load that you are applying. If we're talking about all of the input values, then we would talk about the domain as being their set. And if we talk about the set of dependent variables, we would talk about the range of the variables. So the domain is the set of x or independent variables, and the range is the set of y or the dependent variables. Now, suppose y equals x plus 2. We could write this in lots of ways. We could write it as f such that x is mapped onto x plus 2. We could write it as f of x equals x plus 2. Now, this last way allows us to say, well, if x equals 2, then we can find the value of f when x is 2. And we could find the value of f of x when x is 4. What about if we have f of x plus 2? Now, our input is x plus 2, so this becomes x plus 2 plus 2, which is x plus 4. What about f of 2 of x? This means our input, so our input goes all the way up into there, so then it says 2x plus 2. So we can put an actual function into a function. In general, though, we can combine functions, we can add them, we can find their sum, we can subtract them, so we can find their difference, we can find their product or their quotient. So let's add them. That would be x squared plus 3x minus 2. If we were going to subtract them, if we were going to find their difference, that would be x squared minus 3x minus 2, which would be x squared minus 3x plus 2. We could find their product. Or we could find their quotient. Now with the quotient, we just need to be a little bit careful that the bottom line isn't 0. If we've got two functions, we can perform them end-on. Question then would have to be, is there a difference in the order that we do them? Well, yes, there is. For example, here, if we've got g as being x plus 3 and f being 2x, then depending on our order, yes, it does make a difference. If we do g first and then f, we get 2x plus 3, 2 brackets x plus 3. And if we do f first, then we get 2x plus 3 as our final answer. So it tells us what to do first. If we've got f of g of x, that says do g first, so that's fog. If we have f of x in the bracket, so then we've got goth, then we're going to do f of x first. Oops. Sorry about that. We'll just ignore that there. Newton says that for every action there is an equal and opposite reaction, and the same is true in maths. For everything you do in maths, there's an inverse operation that undoes what you've done. So, for example, multiply is undone by dividing, addition is undone by subtraction, finding a root is undone by finding a power. So we have the same kind of idea here. If we do a function, if we perform a function and then use the inverse, then we should get back with what we started from. So if we've got two functions f and g, and let's look at the second one first, we double the input, as that's what it says under f, to get 2x, and then if we perform g, which says halve the input, we get x. If we do g first, halve the input, we get x over 2, then if we double it, we get x. That is what makes us a function. So we need to be able to actually find a function, the inverse of a function. So what we would do is we would transpose it. So now we've got x, the subject. Then we would swap over or interchange x and y. Then we would check to see that the end result is indeed a function. Now, that may have been missed from right at the beginning. The actual definition of a function is a relationship where for any x, there is only one y. So check to see if it is indeed an inverse, and then we're done. So let's find the inverse of y equals 3x minus 4. So y plus 4 equals 3x, so y plus 4 divided by 3 equals x. Rewrite it up here. Now we're going to swap in the x and the y. Check to see if it is indeed a function, and yes it is. What about this one? Say y equals a third t plus 5. Okay, rearranging it, so we've got y minus 5 equals a third t, so t equals 3 times y minus 5. This is a function. And another clever thing that we can do is if we put this into the original, we will get t out.